Yes, good evening everyone. So in the last videos, I think we are discussing about double linked list. So in this double linked list, almost we performed all the operations except some traversals like that. Let us complete that one also. In today's session, we will finish those operations also. Let us see how we can able to work with that. So you can able to see here what are the operations that we have performed in the last videos. Yeah, insertion insertion of an element, I mean creation of a node class, then constructor we have seen for double linked list, and even we have seen size of the double linked list, how to print, and empty function, how you can able to check whether the given linked list is empty or not, and how to print a double linked list by using iteration and insertion at the first location and insertion at last location. So these operations we covered. So if I execute this particular program, what output we are going to get, you can see here test.py. You can see we are getting these elements in this style. Sir, I need same list, but I want to print this list of values by using recursion. Okay, already we implemented by using iteration how you can able to do, but the same thing I want to implement by using recursion. So print double linked list values. So by using recursion, I want to implement. Okay, let us see how to implement recursion. So I will take the function name as a print list recursion. Recursion. I am taking the argument as a self, and we need some temporary variable, which is nothing but the node, sir. Which node we need to print? So that particular value we are going to give in the form of this particular argument. Okay, so this argument is nothing but whatever we are passing, that argument we are going to traverse. Suppose if the value of temp is equal to none, then we can able to say the list is nothing but empty, and simply we are going to return the control. Otherwise what we are going to do, we will print that temporary node data. Okay, we will print that temporary node data, and end is equal to I am giving space. Okay, so print by using recursion. So temp dot data I am printing, and end is equal to empty. So after this, what we have to do, I am calling print list recursion by passing temp dot next. I am going to transfer the control to the next node. Sir, let us see how it is going to work with the help of a small diagram. If you see, this is nothing but my linked list what I have. This is nothing but my linked list what I have. So in this case, what we are doing, sir, consider this data is 10, this data is 11, and this data is nothing but 12. And this is the next field, and this is nothing but the previous field. This is the next field, and this is the previous field. Last one is none, and the first field is also none. And what is the name of this node head, right? At the time of calling, we will pass this one as a temporary node. Sir, is a temp is equal to none? No, we will print a temp dot data, which is nothing but a 10. Then I will call temp dot next. Now this will become your temp. It will print its data. Again temp tends to next. It will print its data. Again temp tends to next. Last time when temp is equal to none, what will happen? We are printing list is empty. I think instead of this, sir, we can print when the temp is equal to none, better to print none. Like this we are going to get. Now we will run this. But if I want to run this, what we have to do? We need to call this function. I'm going to call, so print list by using recursion. But when you are calling, you have to send a list.head. We need to send the head pointer. By using that head pointer only, we are going to get the restock. Sir, print recursion is not defined. You temp dot next. Since it is a internal function, we have to call by using self. Now you can see, sir, is the data is coming? Yes, but of course I have not given arrow marks. So if you provide arrow marks, then we will get with arrow marks. If you want, you can cross. So this is the way how to print the values by using recursion and the values by using reiteration. Okay. I think you people got very clear idea about this. Can you please confirm everyone is the concept is clear for you people?
Yes, sir.
Yes, please confirm everyone is the concept is clear.
Hello, sir.
Yes, sir.
Sir, while calling by recursion, we don't have to pass self as argument.
No. Self means what? Self represent always current pointer, right?
Yes,
So
sir.
self means current reference. See, when we are creating only, we have to take self. But at the time of calling, we are not required to pass. Automatically, it will take. Okay.
Okay, sir.
Any doubts, friends? Is this operation is clear for you people? So with this print list or
Yes,
display
sir.
function got completed. So just please wait for 1 minute. I will be back. Please wait for 2 minutes. I will be back. Please wait, sir. Right. Guys, can you please confirm? Am I audible? Is my voice is clear? Yesterday notes, I think I have not updated. I will update Ashish today. Yeah, please confirm everyone, sir. Am I audible?
Yes, sir, audible.
Right. So this is the way how we can able to implement which method? Printing recursion, sir. Now, sir, do you know in Python, especially the people who know very well about Python, just concentrate here. Sir, I have a list is there here. I am trying to print that list as it is on the screen. Okay. I have a list is there. I am trying to print that list as it is on the screen. So what will happen? If you run the program, you can see instead of getting the list, we are going to get address of that particular memory location. Sir, where it is located, it is returning that address, but it is not returning the content. Sir, when I'm printing that object, I don't want to get the address reference, all these things. I want to print the total list. How we can able to do? Especially the people who are coming from Python background. Can you please tell me which method we have to implement to return that particular object content directly? Anyone having idea? Yes, please confirm. Please respond. Okay, right. So there is one special method is there with name underscore underscore str. So we have to override this method, sir. Def underscore 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 underscore. The first parameter is self. Sir, it is going to return the data in the form of string. I'm creating a string. At last, we are going to return. Sir, your result we have to add to the string. Beyond that, nothing. So for that, what I'm doing, I'm taking my current node is equal to self dot head. Okay, my current node is nothing but what? Self dot head. So until that means while your current node is not equal to none. So till that what we are going to do? Sir, we are going to get the data. Instead of printing that data, I am trying to add that data. So in a formatted string so that it will be converted into string format. So here I'm going to take a current node dot data. Current node dot data. Sir, I captured the data and I appended to the string. How to get next data? Current node will become your current node dot next. So this loop is keep on running, sir, until to get the last node. Once if you got last node, yes is equal to already available yes, plus try to put none. Try to put none. If you want, you can give arrow mark also, no problem here. So that what will happen? So finally we are going to return. So this particular function is going to create a special string format for this. In this string, slowly it is appending the data. Which data? Suppose if I have 11 is there as a first node, 12 is there as a second node, 13 is there as a third node, 14 is there as a second node, last node. Now what will happen? It will take the first node and it will add and it will give arrow mark, and 12 it will give arrow mark, 13 it will give arrow mark, 14 it will give arrow mark, at last it is going to add none and it will return this particular string. Sir, if list is empty, what will happen? These things won't be evaluated. Only we will get none. So like this, it is going to work. But let me cross check really whether it is working or not. Sir, in this example, you can see at the last, we are trying to print the list. Okay, now try to execute. Sir, are you seeing the same thing? Yes. If you call, okay, if you call, so print list, okay, print list or list dot so print list by using iteration, okay, or you can call print list by passing recursion. Sir, all these things are going to return the same output or not? Print iterative or iterative. For recursion, we have to pass list dot head. First pointer we have to pass. Now you can able to see. So all these three functions are returning the same content, right? So for display operation, how many possible ways are there for us? We have total 3 possible ways are there. I think you people got very clear idea how we can able to work with this, right? Please confirm, friends, any doubts up to this?
No, sir.
Right. Sir, what about remaining students? Please confirm. Is it clear?
Yes, sir. Confirm. Clear.
Right. So the next one, I mean, this one we finished. Which one? Overriding string representation. Now we have to see inserting the element at a specific location. I want to insert the data at a specific location. We have to see. Let us see how we can able to work with that. So here I am going to take insert at a given location. So they have given a location. In that location, we have to add the element. So def, what is the function name that we have to take? So insert at a given location, like this I am taking, where I will pass the first argument as a self, which index value you need to take. That index I am giving, and what is the data that you are supposed to store. Now, by mistake, the index value which you have given is less than 0, or the index value which you have given is greater than self dot size. That is, it is greater than the elements present in the list, means then we are printing a simple message saying out of range, I can't able to add the objects, and simply I am going to return the control. Okay. Otherwise, what we are going to do? We are creating a new node. We are creating a new node with a self dot node by passing so data as argument. Next field is none. Previous field is also none, since it is a double linked list. Now we have to see the possible cases. Let us see for this example purpose. Insert at last 111, insert at last 222, insert at last 333. So insert at last 444, insert at last 555. Like this, we have total 5 elements are there. So let us see how this we are going to add. So already we have a nodes are there. Like this is nothing but the first node what we have with the content 311. Now we have second node is there. So with the content 322. So third node we have with the content 333. So fourth content we have with the fourth node we have with the content 444. And the last node we have with the content 555. Like this, total how many nodes are there? 5. This node next field is this one. This node previous field is this one. This node next field is this one. This node previous. Next field and previous. Next field and previous. And what is the name of this particular first node? It is always called as a head node. And we have given the tail node also, right? We have given tail node also. So this last node will become what? Our tail node. Like this we have. Assume I want to insert the data called 999. Where we need to insert this 999? Sir, we need to insert in between these. What is the location? 0, 1, 2. So in third location, I want to insert. The location is nothing but what? 3. And this node name is nothing but what? New node. Like this we have. Sir, now we have some corner cases are there. What is that corner case is? Sir, after creating the node, what is the next step? Self dot count is equal to, so self dot count plus 1 I am taking, because we created a new node, right? Automatically it is our duty to increment a count variable by 1 unit. So after this, what we are going to do? Sir, I am checking is the value of index which you have given is 0. So means what? You are trying to insert at a 0th location. Sir, if you are trying to insert at a 0th location, that means if you are trying to insert this value at the beginning, Already we have code for that, right? So what will happen? This is the code. So self dot head dot previous will become new node, and new node next will become self dot head, and self dot head will become new node. Like this we have to write. Have a look once. If index is equal to 0, this is nothing but the code what we have. That means when you are trying to insert the element at which position? 0th position. So automatically what will happen? This new node we are trying to add in this particular location. Then what will happen? Self dot head dot previous. This is nothing but your head node, right? So it's a previous field I am attaching to the new node, and the new node next field I am attaching to this head, and then this will become your head. Like this we are going to take. It is a very simple. Already we have studied this code. Okay. Already we have studied this code. No need to look into this. So when this will happen? If you are trying to insert the element at 0th position, sir, and then we are going to return the control. Now I'm not inserting at 0th position, sir. Suppose the index value whatever you have given is self dot count minus 1. That means we are trying to insert the element at which location? Last location. Sir, if you are trying to insert at last location, then what will happen? Sir, it is the same like insert at last, right? It is the same like insert at last. Already we have code for that. Just I am going to take this code as it is. So what is the code for this? You can able to see. Sir, we are trying to insert the value at last location. Now, if you are trying to add at last location, then what will happen? Sir, this is your new node. This is your new node. So tail new node dot previous will become self dot tail. New node is there, right? So one second, something is missing here. Yes, your new node is there, right? It's a previous will become self, I mean tail. Then what we are doing? So self dot tail is there, right? Its next field will become new node, and this will become new node. So when it will be happen? So if the value which you are trying to insert is available at 0th location, or if you are trying to add the node that we need to insert at the last position. If a position is equal to 0 or position is equal to n minus 1, so this is nothing but the situation what is going to be happen. Sir, other than this, if you are getting anything, then we have to insert at appropriate position. So in this insert at location, is these two corner cases are clear for you people? Please confirm.
Yes, sir. Yes, sir. Clear.
Right. Now what we have to do? Our main task is, so in these two positions, it is not there. We have to find its appropriate position. See how I am going to write. Sir, I will take one pointer like temp1 is equal to self dot head, and I am taking temp2 is equal to none. Index value is equal to 0. So while there is a loop, so temp1 is not equal to none, and your I value is less than index. So then what operation I am going to do here? Very simple, sir. Here temp2 is equal to temp1 I am taking, and temp1 will become temp1 dot next. I am moving to the next position. So after this, your I value will become I plus 1. Like this I am taking. So means what? Sir, you can cross check. I am writing in the blue color. Have a look once. Sir, this is a temp1, which is nothing but a head. And my temp2 is nothing but what? It is a none, sir, initially. Now see what will happen. I value is equal to, initially I have taken the initial value of I as a 0. Now you can see, is temp1 is not equal to none? Yes, temp1 is not equal to none. Is I value is less than index? So what is the index value that we have given? 3. Yes, it is satisfying. Then temp2 will become temp1. This will become temp2, and temp1 will become temp1 dot next. I is equal to I plus 1. Now we are checking, is temp1 is not equal to none? Yes, temp1 is not equal to none. Is I is less than index value? Yes. Then what we are going to do? this will become your temp2 and this will become your temp1. So now what we have to do? Sir, I value is also incremented by 1 unit. Temp1 is not equal to none. Yes, temp1 is not equal to none. Then I is less than index. Yes, it is also less than. Then temp2 will become temp1 and temp1 will become what? Temp1 dot next. Like this we have. Now your I value will become 3. So next time temp1 is not equal to none, but I less than condition is not satisfied. That means we came to the proper position. Now this pointer reference is nothing but what? I will highlight with. So this pointer is a temp2, this pointer is a temp1. Now you have to insert this 999 in between this. So what is the code that we have to write? We have the names, right? So temp2 dot next will become new node. Is it correct? Yes. Then new node dot previous field will become temp2. Then new node dot next will become temp1. And temp1 dot previous field will become new node. Now see the links how I am going to attach. So temp2 is there, right? Its next field is new node. Temp2 is there, right? Its next field is new node. And new node previous is a temp2. This is the new node, its previous is temp2. And new node next field is a temp1. Like this we are attaching. And temp1 previous node is nothing but what? New node. Like this we attach. So here you can able to see how this new node got attached. Can you please confirm, is this insert at a specific location operation? Is it clear for you people, guys?
Yes, sir.
Is it clear? Please confirm. Yes, I request
Yes,
everyone
sir.
to please respond.
Yes, sir.
Clear.
Yes, sir. Yes, sir.
Right. But we need to cross check whether it is working properly or not. So what I'm going to do is, so I will try to call list dot. So insert at a location where I'm giving the location as a 0. Consider the element is 999. Let us cross check, is that value is added at first 0th location? Yes. Now give the location as a 1. Is it added at first location? Yes, you can see. Sir, I want to give the location as a, is it added at second location? Yes. Now I want to add at third location. Yes, perfectly it is added. So I want to add at fourth location. Perfectly it is added. I want to add at fifth location. Sir, perfectly it is added. I want to add at sixth location. Perfectly it is added. No, because the sixth location is not there, right? If a sixth location is not there, immediately we are going to get error message saying out of range, we can't able to insert the data. So this is nothing but how we can able to work with this insert at a specific location. Yes, insert at location also got completed. Any doubts, friends?
No, sir. No, sir.
Right. Next, we will see the next operation, delete at first, delete at last. Okay. So delete at first, delete at last, we will see. Sir, let us go for the next method, what we have. So delete at first. So def, so delete at first I am taking where the argument is a self, where the argument is a self. So now what we have to do? If self dot head is equal to none, that means there is no more element. Simply I am going to print the message saying list is empty. I can't able to insert and simply return the control. So otherwise compulsory element is there. We have to delete. Self dot count will become self dot count -1 and first position, right? That's why self dot head will become self dot head dot next. And we have to check is self dot head is not equal to none. If self dot head is not equal to none, self dot head dot previous field will become none. Let us see the explanation of this. For example, consider I have a linked list is there with some 4 elements. Okay. So this is nothing but the first element what we have. I mean first node. Let us consider the data is 11. And the second node we have, let us consider the data is nothing but 22. So let us consider we have another node is there So the data what we have is 33. Assume we have one more node is there with the data as a 44. So this is the last node. Next field is none. And this node next field is this one. This node next field is this one. This node next field is this one. This one. And the next field and the previous field. And its previous field is none. And this node is pointed by head. And this node is pointed by tail. Already we have these two pointers are there. Now see what will happen. We are checking is the self dot head is equal to none. Okay. We are checking is the self dot head is equal to none. Sir, is self dot head is equal to none? No, right? So we have some content is there. Then what we are doing? So count is equal to count minus 1. So we have to delete. And self dot head is equal to self dot head dot next. This is the self dot head, right? So self dot head dot next means this one. Now my head pointer is pointing. Okay. Sir, my head pointer is going to point to the next node like this. Then we are checking is head is not equal to none. Yes, head is not equal to none. Because once if you assign like this link will be deleted, but a previous link will be there. That's why we are checking is it none or not. When it will be none? When you have only one node, then simply we can able to remove. So pointers deallocation is not required. But here self dot head dot previous is equal to none I am taking, so that by default it will be removed. This is nothing but what we have deleted first. So by default this node is eligible for garbage collector. Can you please confirm, is it clear up to this?
Sir, can you
Yes, sir,
repeat,
clear.
sir, again?
Sir, nothing is there here. Why you are getting confusion? See, this is my initial list, right?
Yes, sir.
You can see here self dot count is equal to count minus 1. How many nodes are there? 4. That will be reduced to 3.
Yes, sir.
And self dot head dot next. This is the head, right?
Yes,
Its
sir.
next field is nothing but 222. Now I am taking head is equal to this node. That means what? So now onwards, so your head is pointing to this particular node. Once if you move head to here, automatically this link will be erased, right?
Yes, sir.
Because we can't, we don't have any name for this. If there is no name, how you can identify next node? It is not possible. But if you are having a name for this 322, we can identify the previous node. That's why I'm checking that condition. What is that? So after assignment, if your head is not none, then what will happen? So head dot previous field will become none. That means this node will be deleted. Suppose when this condition is not going to be satisfied, you can see, assume I have only one element is there. This is nothing but none, and this node is nothing but a head. Now what we are doing, we have only one node is there. Self dot count will become count minus 1, it will become 0. Then self dot head is there, right? It will become head tends to next. What is a head tends to next? None. Now my head is pointing to none. Automatically it is deleted. So is self dot head is not equal to none? No, it is equal to none. That means no need to call previous, right? Automatically it is none. Got
Yes.
it, sir?
Yes, sir. Okay, sir. Thank you, sir.
Right. Let us see for execution of this particular code. Now what I am going to do, so we have a list is there, we have to delete from the beginning. So delete at first I am taking. So automatically that node is going to be deleted from the beginning. You can see the first node got removed. So I think this double linked list with the deletion at first is very clear, right?
Yes, sir.
Right, sir. So remaining operations, we will continue tomorrow, sir. So tomorrow we are going to discuss about this particular concept, and mostly I am going to wind up this double linked list program tomorrow. Okay. And Saturday, I may take the class. Okay. I already told morning 10 a.m. to 12 noon. We have a separate concept is there called a stack. Anyway, Sunday there is no class. Okay. We are going to see this stack concept, how this stack is implemented. So how to write the programs, those things we are going to discuss on which class? Saturday class. Okay. Right, sir. Thank you. We will meet for the continuation tomorrow. I will upload the running notes within a few minutes. Okay. Thank you, sir.
Thank you,
Thank
sir.
you, sir. Thank you, sir. Thank you.